Welcome to Covestro. I'm sorry, I had a slight itch here. We have some seats available. If you knew how many miles you will be walking today, you'd be happy to sit. And they're really nice. They're made of an extremely nice and comfortable foam, so you can really sit down and enjoy the show, because we do have a show coming up. We also have content. We have a presentation coming up, as you know, because you've seen the agenda. But first of all, let me welcome you officially, ladies and gentlemen. As you might have already noticed on the K-Fair, major shifts are taking place in the plastics industry. They are transforming the entire industry, and as a consequence, Covestro has a very clear approach towards turning the United Nations Sustainable Development Goals into a proper reality. Now, Covestro explicitly advocates a comprehensive and a global approach towards all of these sustainable development goals. Now, we know that this is very abstract, so let us take a look at 2 or 3 of them, okay? For example, the goal number 2, which is called zero hunger. Now, behind this is the question of how we want to produce, distribute, and consume our food. And if you look at the local farmers in developing countries, for example, you can see they face a major challenge. They produce more than enough food, but sadly, most of it ends up in the trash. They simply do not have the capacities for keeping it cool. And this applies to an estimated 30 to 50% of their harvest. Enter the solar dryer. It was developed in cooperation with Dr. Sernjan Jai from Silpakorn University in Thailand, and it functions as a sustainable drying system for fruits and vegetables. Now, how does it work? Open up! The solar dryer employs very high temperatures. Thus, it dries products like bananas, tomatoes, chilies, or even herbs. This extends their shelf life enormously. And of course, it is very energy efficient and eco-friendly. Now, Covestro delivers the raw materials for this project. It is used for the PCS bar plates that have superb insulating features. Now, the system is really easy to transport, and it can be assembled locally. More than 500 systems are already in place in Thailand. Bottom line, the solar dryer reduces the risk of food spoilage. 50% less have to be thrown away. At the same time, the solar dryer contributes to society. It improves the farmer's income without polluting air, waters, or soils. Which brings us to our second quick example, the Sustainable Development Goal number 13, climate action. At Covestro, this is about energy-saving chlorine production. Now, about 2/3 of all chemical products need chlorine for their production. For example, plastic, of course. Now, the kind of energy needed for that is electricity. Actually, quite a lot of electricity. You could even say too much. Now, Covestro helps to change that. Together with their partners, they developed a process that reduces the amount of electricity needed by 30%. How do they do that? Well, the principle of chlorine production has been well known for more than 100 years. It works via electrolysis, as you know, meaning you send a current through a saline solution. The novelty within this process, which is newly developed by Covestro, is the hydrogen-producing electrode is replaced by a so-called oxygen depolarized cathode. Can you repeat? Oh, exactly. And the main thing is, it works with 2 volts instead of 3, okay? Thus, it only needs 2/3 of the voltage. That's the important thing. If you'd use this process for Germany's entire chlorine production, it would really reduce Germany's total power consumption by 1%. That's how powerful it is. And in the upcoming years, Covestro will introduce this process in 2 of their plants and save up to 40,000 tons of CO2 per year. Which brings me to one last quick example. The United Nations Sustainable Development Goal number 8, decent work and economic growth. The answer from Covestro is the Startup Challenge. With this, Covestro offers a worldwide internal competition where courageous entrepreneurs are sought out and approached. The special thing about this is it is a great chance for in-house startuppers. They get the opportunity to independently push their business idea until it reaches market readiness. They are entrepreneurs within the enterprise. But first, these entrepreneurs have to convince the others of their ideas. Now, they really have to pitch them to the board of management from Covestro. And ta-da! They have succeeded. Now the two winners are relieved of their normal job duties because from now on they run their own startup. They have 12 months, 1 million euros, and they even have time to party. And they have to turn their idea into a reality. And as you can see, the startuppers really have a lot on their plate during this time. They have to learn a lot, thinking like an entrepreneur, trusting their own efficacy. But of course, they are not entirely on their own. Together with their team, they work in a workshop or a lab where they constantly improve their idea. And finally, the product is ready, and it even turned out better than ever imagined. Now, they have to find someone to sell it to, okay? So stop partying, off you go, boost those sales. Now, ladies and gentlemen, these examples show how Covestro employs the United Nations Sustainable Development Goals for our planet's brighter future. And there is so much more we can do. We can contribute in many different ways, big or small. For example, with innovative surfaces inside the car and what Covestro can do to advance the development of display surfaces. And in order to find out, I have the pleasure to welcome the two project leads from large 3D multi-display surfaces. They will bring us a keynote with a lot of technical background, also with a lot of wow pictures, and it will lead you directly to the live demonstration with the key exhibit over there with mobility and transportation. And the two of them will actually be there, and they will answer all the questions that you have, and many more. But first, let's give them a heartfelt welcome. Here are the two project leads from Continental. We welcome Martin Lenz, and from Covestro, Andreas Müller. Gentlemen, the stage is yours.
Okay, thank you very much for your introduction, Carl. Andreas and I are very proud to present you today our project we have developed the last 2 years.
So, what can you expect in the next 20 minutes? So first we get a short introduction to company Continental. Then you learn a little bit about the evolution of human-machine interface systems, followed by what we call the new dimension. And then we go a little bit more into details, talk about partners and technologies. And if we are all lucky, in 20 minutes we close with a conclusion. Martin.
Okay. At first, some numbers about Continental. Continental is founded in 1871 with headquarters in Hannover, Germany. We have sales per year about 44 billion euros. We have 245,000 employees in 544 locations in 60 countries. We're organized in business units, five business units: chassis and safety, ContiTech, powertrain, tires, and interior. Today we will focus on the business unit interior, and to get a little bit closer what we want to do tomorrow, we have to take a look to the past, what we have done in this business unit. I will show you at the next slide. Our first serial production project in this business unit was the Eddy speedometer. This speedometer we developed in 1904, produced it several years, and only shown the velocity of the vehicle. Next evolution step was the analog instrument cluster. In this cluster, we use a lot of plastic materials for parts like pointers, frames, or cover glasses. After that, we combine the analog information and the digital content in one cluster. Mostly, the digital cluster was centered in the instrument. I think this picture is very familiar for the most of us. The last 4 years, we see a lot of large multi-display surfaces, seamless, most 2 displays or more under a real glass surface. The control of this kind of instrument cluster was done by touch pads or rotary knobs. For better touchability, we need to bring the center stack closer to the driver. We developed on surfaces which are curved, 2.5D curved, to bring the center stack closer to the driver for better touch operations. To increase the design freedom, we develop on alternative materials to real glass. In this project, we have a lot of plastic, hard-coated plastic materials for cover lens surfaces developed, and 2.5D curvature in the display areas. The next evolution is a real 3D topology on a flat surface. Why does we need that? To make the control, the touch controllability safer, we need a guidance for our finger by control the fan or the volume or someone else. And the question is why we're here today, what's next? Yes? What's the next evolution of our holistic human-machine interfaces? In my point of view, it's very easy. The next evolution is to bring all these awesome features in one cluster. We have a S-shaped curvature multi-display surface with 2 12.3 inch digital cluster or AMOLED displays. We have, more in detail, I will show you a real 3D topology on the sliding areas who will guide your finger by touch controllability. We have some active haptical feedback response by touching the plastic surface. And we have seamless transition of decoration pattern into the display areas. All right. For such a system, we have a lot of technical requirements for the cover lens. I will bring you that nearer. In emergency cases, we need very ductile materials for head impact or someone else, safety performance in crash situations. We need a very high heat resistance because our displays will get brighter and brighter. We need materials which is suitable for maximum design freedom to realize all customer needs designs. Of course, all materials we use need a long-term durability, and also non-conductive materials for a good touch controllable. Last but not least, all materials we use has to be a high quality appearance to make a comparison to established materials, possible. For our cover lens, we choose polycarbonate material, polycarbonate-based films, and IMD technology in hard coating. Why? Why we fulfilled all these requirements with these 3 materials. Okay,
Good.
At this point, we know which kind of materials we use, but we need more than materials. We need also a strong partner. These strong partners developed with us a lens like that. These strong partners has to be a deep knowledge in polycarbonate technologies.
Yeah, and as somebody said years ago, there was somebody saying, yes, we can. We say, yes, we have. We have experience in polycarbonate since 1953, when it was invented, I would say, by a former colleague of us.
Okay, we need a partner with deep knowledge in film insert molding technology.
Yes, we have. We started the film insert molding technology roughly 25 years ago, and we have a huge number of projects running.
A partner who's able to customize their own materials with colors or some else.
Yes, again, we have this experience. This is one of our core competences. So we have hundreds of grades and thousands of colors, all depending on what our customers wish or need.
Okay. And also a lot of experience in big size transparent plastic parts.
You know what's coming? Yes, we have. We started the automotive glazing, so we call it automotive glazing technology, roughly 20 years ago. And what you see here on this picture is a typical sunroof, so we think we have experience in big size transparent plastic parts.
Okay. And also technical expertise.
Yes, we have. What you should see on the picture is that we can give support from the first concept and ideas up to the serial and mass production and all the steps in between. So this means we do rheological analysis, we do mechanical analysis, we can support during part and mold design, troubleshooting, optimization, everything along the process chain.
All right. And also we need a suitable environment with technical machines, with suitable machines and labs.
Yes, we have. We run technical centers all over the world, in all the big regions. And in our center in Leverkusen, close by, we run, at the moment, 8 injection molding machines. We start with a clamping force of 50 tons and end up at 2,300 tons.
All right. It's also important to have a big network in industries and partners.
Guess what's coming? Yes, we have. I had no space to write down all the names of the companies, but what you see here is that we have a network to universities, to tiers, to OEMs, to customers, to tool makers, whatever you can imagine.
And last but not least, it's also very important to have a partner who's established in the automotive market and has the same mindset in future trends like Continental.
I don't say yes, we have. I simply say yes, this is us, this is Covestro. And in one word, bingo.
Bingo.
Okay.
All right.
So, knowing what we want to do, I give you a short overview about our principal layout. And we try to make some kind of exploded view. So what you see here is the front layer, then we have a backside layer and the layer in the middle. We are a bit, or let's say much better in developing an application than taking a picture of it, but please believe me, that's the principal layout. So what had we done? So on the first surface, in the front, we decided to go for the in-mold decoration technology. In this case, we use the Bright View film from company Kurz. And the main task for this first layer is protection. On the back side, we have the film inset molding technology. And we decided to go for our Macrofol HF 312 film. And we have a decorative printing on the front side of the film and a hardcoat layer on the back side. And this hardcoat on the back side should give some advantages for the optical bonding of the OLED displays later on. Last but not least, in the middle, the carrier is the polycarbonate. And by the way, in this region, we don't say polycarbonate, we say Macrolon. We use the Macrolon AI 24/17 in this case. And if you wonder, what is AI? AI for us means automotive interior. This is a, let's say, newly development family of materials within our Macrolon portfolio. And yeah, it was developed, surprise, for automotive interior applications. Yeah, this is what we want to do. And now Martin will show you a little bit more about the technologies used.
Okay, thank you. In my point of view, the challenge in this project, or one of the big challenges, was to bring all these advanced process technologies in one tool. I will show you some little information to get closer to my concern. By in-mold decoration, there is a film, roll to roll, which is guided by a foil feeder to the moving tool site. The tool needs some special clamping frames and vacuum holes to fix it in the cavity. After the fixation, the tool closes and the film will be back molded. By demolding or by opening the tool, the hard coating layer on the film will stick to the part, and the release layer, the transfer film, will stay on the moving side of the tool. After I pull out the part is finished, finished decorated. First surface finished decorated. That's the in-mold decoration stack. Film insert moldings, a little bit different, but also advanced technology. We have a 3D form film, which we put into our cavity. We close the tool, back mold the film, the 3D form film. After ejecting, the film is a solid part of our cover lens. And the second surface is ready decorated. For a high quality appearance we need for products like, or for cover lenses like that, we use the injection compression. By injection compression we need a special sealing frame which seals by the injection phase our parting line. We close the mold up to the compression gap. After injecting, we close the mold complete. And at this point, we have a homogeneously pressure level by cooling in the whole part. And after injecting, our part is finished. All right. This was challenging, but I think our process flow was also challenging, and Andreas will tell you why.
Yeah. Thanks. So what you see here is the different flow paths in our process flow, and what you see in blue is the film insert molding step. Typically, you start with a 2D film, then you do some screen printing or digital printing, and then you could use the film. But if you try this in a mold like ours, I could say, good luck, have fun, no chance. So we need some preforming of the film, as Martin explained before. And therefore, we decided to go for the HPF technology, high pressure forming technology. So a tool was built. Then we did some preparation of the films to fix them in the tool. And then we used a high pressure forming machine, and this is what you see here. So this is the world's largest high pressure forming machine developed by company Niebling. The sheet size is, I have to look it up, 1,150 by 650 millimeters. We have 60 different heating zones and I think a force of 1,000 tons. So quite impressive. After the forming, we do the UV curing, some trimming and checking, and then the film is ready. In green, you see the IMD step. So for in-mold decoration, it's a little bit different. Typically, we start with a coated or printed film, and then we use what Martin explained in his pictures, the foil feeder. And then you see the word IMD heater. What is an IMD heater? An IMD heater is used to heat up the film. Why? We have a very high degree of deformation of the film, and we have to make sure that it really covers every little detail in our cavity. And how can I make a plastic flexible? I heat it up. So in this case, we have 6 different heating zones. You see that the heater is following the shape of our part. And with these 6 heating zones, we can, if we need, bring the heat exactly in the area where it's needed. Then the film is more flexible and can be sucked by the vacuum completely in the cavity. This is why we use the IMD heater. After this, the tool design started. And you see the word pre-testing. What have we done? As this was really challenging with the IMD, we decided to have an evaluation step in between for the IMD. And believe me, it was a good idea to do it, because otherwise we would have been in deep trouble. Then we have the tool. One picture to get an idea. So the complete weight of this mold or tool is 16.5 tons. Yeah, in Germany we would say, this is not a children's birthday party. Yeah? This is real life. This is a mold, a tool, so I always say mold. This is a tool close to serial production. And we have to implement all these technologies. And every technology needs some special devices. Yeah, and therefore, you get the mold bigger and for sure more heavier. What makes this interesting is a feature that the mold is, let's say, controlled by itself. So we have a wireless LAN SPS that can then be programmed by a mobile phone device. It was quite nice idea. Okay, you see more or less everything's ready. We have the film, the IMD, and the tool. What is missing? Missing is, correct, the injection molding machine. And due to certain reasons, we decided to use our 2,300 tons machine. So don't worry, we do not go to the restroom with the microphone switched on. We just want to show you one thing. So this is roughly the size of this machine. That you get an impression what's going on here. It's a 2K molding machine with, for sure, injection compression capabilities. And we have a clean room installed. And first of all, we have a rotating middle plate. We have a clean room installed and a floor box on top. And if you have eagle eyes, you may see the pointer is not working. So this is where the machine starts, and it ends up somewhere there. And this is used to really create high-quality optical parts. Ein Klick noch. Yeah. So everything's ready. And if the equipment is running and your process flow is flowing, then you can produce a part like this.
I will use this moment to say something. The target was not to create 2 or 5 golden samples. Our target in this project was to validate the process technologies in these dimensions with these advanced materials and technologies to a high maturity level. I would say to a serial production maturity level. And this is our target, and this is what we develop in the past, today, and in the future. The part has length about 800 millimeters, a width 200 millimeters. We have really 3D curvature. We have 3D topology in the sliding areas. We have, yes, a S-shaped or a deep of the part in the displays, about 1,500 millimeters. That's some very impressive numbers in my point of view. Last but not least, the part is very thin and the second surface is decorated. Why we do that? We want appearance like real mineral glass. And this is why we do that this way. Okay. Not only Covestro and Continental developed on this part, we have a lot of another partner. I will say something about it. Covestro, yes, supported with, we have said enough, I think. Company Niebling provide us their HPF forming machines, their large HPF know-how. They build up our HPF tool and support us with, yes, with making some samples. The company Sumera Technologies built up these complex tools. I think we designed the tool 7 or 8 months, sorry for that. A lot of technical know-how in these technologies. I think very, very good partner for a project like this. And last but not least, the company Kurz provide us their IMD films, their IMD foil feeders, and their large IMD know-how, in mold decoration know-how. All right, at this point, I want to say thank you to all our cooperation partners, and I want to say thank you to you for your attention. Thank you very much.
That's it. Thanks.
That was an absolute Punktlandung, as they say in international German, on this very booth. And now I promised you that they will be around. You can actually ask them all the questions that you know, because you've got colleagues here, right?
Yes.
And if we would have them ask you questions, that would go on forever. And we've got the next show coming up at 3 o'clock, so we have to clear everything and prepare everything. If you want to come back at 3 o'clock, you're more than welcome. Actually, I would drag you here if you're not showing up. But if you want to ask them any questions, just follow the 2 gentlemen to the exhibit right over there, which is not as big as the machine, but you can show something. Yes?
Definitely.
Okay. Big round of applause and have a great day here at K-Fair.
Thank you.
Thank you very much.
So.
Ja,
Hier.
mache ich gerne.